Dear teacher, my name is Yuan Gao and my student ID is S3690168. My course is Analysis of Complex Structure. Today I'm going to talk about video project task 3. First is an introduction. From the task 1, we choose a bridge and make an analysis. I choose a Surrey Bridge. It's located near Flinders Street and it is an indeterminate structure, and for part of bridge, we analyze it. In task 3, we use the moment distribution method and the approximate method to analyze it. First is the moment distribution method. There is no side V, and we calculated the distribution factor first. dfab equal to dfbc equal to 1 because of the pinner joint. dfba equal to kba divided by kba plus kbc. Use the formula for EI divided by L. We got the answer is 0.75. The dfbc equal to kbc divided by kbc plus kba. The answer is 0.25. For dfcb is kcb divided by kcb plus kcd. The answer is also 0.25, and dfcd equal to kcd divided by kcd plus kcb. The answer is 0.75. And the next is the FEMS. The full name is fixed end moment. And for FEMBC equal to negative WL squared divided by 12. The answer is negative 719.28 kilonewton meter. FEMCB is WL squared divided by 12. The answer is 719.828 kilonewton meter. For FEMAB, FEMBA, FEMCD, FEMDC, they all equal to 0 because there's no load on AB and CD. For table iteration, there we just list the table and the joint A, B, C, D members ACBA, BC, CB, CD, DC. DF and FEM we already calculated before, and start with the DIST1. We just use 719.28 times df in BA times 0.75. We got the 539.46. And also use the 719.28 times 0.25. We got the BCDIST equal to 179.82. For CB and CD, it's the same, but it's a negative sign. And for CO1, we use the 179.82 times 0.5. We got the 89.81. And for BC is a negative sign. And we keep the same steps until the DRST5. And the last is about the total moment. The total moment is 616.44 for BA. For BC is the same but with a negative 1. For CB is a positive. For CD is a negative. And the next is a bending moment diagram. And next we will move to the approximate method. For this method, we first divided the structure into two parts, section left and section right. And it has FEX, FEY, FDX, FDY, EX, and EY. At the beginning, we assume sigma MA equal to 0, and also assume sigma MD equal to 0. And we got these two formula. The first is the left one, the second is the right one. Use these two formula, we got the EX equal to 219.78 kilonewton and EY equal to negative 26.64 kilonewton. And for section right, when sigma y equal to 0, use the formula. We got the FDy equal to 266.4 kilonewton, FDx equal to Ex equal to 219.78 kilonewton. For section left, when sigma m5 equal to 0, also use a formula. We got Fay equal to 213.21 kilonewton. Fax equal to negative 59.94 kilonewton. And next we will calculate about the moment and force. First, we just divide it into 3 part x1, x3, and x2. And for section, we will calculate the section AB. For section AB, we got the equation fx1 minus 59.94 minus 26.64 times x1 equal to 0. We got fx1, which limited 0 to 6. For mx1, we have the equation negative 13.32 x1 squared minus 59.94 x1. When x1 equal to 0, fx1 equal to 59.94 kilonewton, mx1 equal to 0. When x1 equals to 6, fx1 equal to 219.78 kilonewton, mx2 equal to negative 839.16 kilonewton meter. And we continue the same step for section BC. When sigma m equal to 0, fx2 plus 213.12 minus 26.64 x2 equal to 0. fx2, we got fx2, and which limited 0 to 18. For sigma m to 0, we got the equation mx2 equal to 213.12 x2 minus 13.32 x squared minus 839.16, which limited 0 to 18. When x2 equal to 0, fx2 equal to negative 213.12 kilonewton, mx2 equal to negative 839.16 kilonewton meter. When x2 equal to 18, fx2 equal to 266.4 kilonewton, mx2 equal to negative 1318.68 kilonewton meter. And the last one is section CD. Sigma m equal to 0, fx3 minus 219.78 equal to 0. We got fx3, which limited 0 to 6. When sigma m equal to 0, we got mx3 equal to negative 1318.68 plus 219.78 x3, which limited 0 to 6. When x3 equal to 0, fx3 equal to 219.78 kilonewton, mx3 equal to minus 1318.68 kilonewton meter. When x3 equal to 6, fx3 equal to 219.78 kilonewton, mx3 equal to 0. And the last step is about the shear force diagram and the bending moment diagram in the right. And the last for the task 3 is the conclusion. I just make a comparison between the moment distribution method and the approximate method. And there's appendix. There are 3 appendix. First is about video project task 1, and the second is video project task 2. And the last appendix is a CES. And that's all. Thank you.